Welcome to Brunda Engineering Academy. In this video, we have to discuss about the system of forces in engineering mechanics. This concept can be helpful for ECET, GATE, RRB, APPSC, Polytechnic, and as per BTech syllabus also we have discussed. Complete information will be there. Here, the first concept is triangle law of forces. Triangle law of forces. In the mechanics, triangle law of forces. The statement is how the statement if two forces acting on a body, suppose I'm considering here, observe understand the statement, we can easily remember. If two forces acting on a body, here this is the body, let us assume it is the body, the point O. Now two forces are acting at the point here. Now it is force P and another force Q. Force Q. These two forces are acting at a body and these are making an angle of inclination alpha. Now the statement, if two forces acting on a body are represented by the sides of a triangle. Let us assume this can be formed by the sides of the triangle. Then their resultant is represented by the third side of the triangle. Third side of the triangle. So that means for understanding, here it is the one force, that is the P, and another force. Here it is another side. So here 0 mean O, A, B. These two forces are acting as the sides of the triangle. Then the resultant, for these two forces, the resultant represented by the third side of the triangle. What is the closing side? It is the closing side of the triangle. Closing side, but closing side, the triangle taken in the opposite order. Taken in the opposite order means in the opposite direction. Here the direction is important. So it is the resultant force. This is the force P and it is the force Q. That resultant makes an angle of inclination here theta, and here the angle with the horizontal of this force is taken as the alpha. Now the statement is if two forces acting on a body represented by the sides of the triangle, it is one side and it is another side. Sides of the triangle, then the resultant is represented by the third side of the triangle. It is the third side of the triangle. Okay. Next, it's a conversion. Is a conversion of a triangle of forces. If three forces acting at a point are in equilibrium, suppose three forces are acting at a point. So here, these are the three different forces acting at a point. That means it is the concurrent forces, concurrent system of forces. If three forces are acting at a point or in equilibrium, then they can be represented by in magnitude and direction by the sides of a triangle taken in order. So if three forces are acting as a concurrent forces, then their sides, here it is one force, suppose I am taking here, and here another side of the triangle, and it is the another side of the triangle, three sides of the triangle. So here we can represent like this: force F1, force F2, F3. The conversion of the triangle of forces is the three forces acting at a point. Okay, F1, F2, F3. If three forces acting at a point are in equilibrium, then they can be represented by the magnitude and direction by the sides of the triangle, by the sides of the triangle taken in order. Now discussion about the resultant here. Here we can easily, the three forces can be represented by the sides of the triangle. That is the conversion of the triangle of forces. Next, coming to the polygon law of forces. Actually, what is meant by polygon? If any geometrical shape that is having the more than four or more, four sides, okay, four or more sides, then that is called as the polygon. Now coming to the polygon law of forces, if any number of forces are represented in magnitude and direction, number of forces are represented in magnitude and direction. Suppose I am considering one body. Here the force is F1 and another force acting like this. It is the F2 and here F3 and F4. F4. That means here four forces are there. Four forces means that will be forms the polygon. That can be forms a polygon. If any number of forces are represented in magnitude and direction by the sides of the polygon taken in order, their resultant is represented by the closing side of the polygon taken in opposite order. Always the resultant is the closing side of the polygon. Resultant is always closing side of the polygon taken in opposite order. Suppose for this type of case, it is the F1 force will be acting like this, and F2 here, F2, F3 force here, it is the F3, and here F4 will be. These are the four sides of the polygon. Then the resultant will be the closing side of the polygon taken in opposite order. Then the resultant will be closing side of the polygon and taken in opposite order. Opposite order means here that is opposite direction. Opposite direction. Okay, this is about the polygon law of forces. Next, coming to this one, conversion of polygon law of forces. Polygon law of forces. What is the statement? If a system of congruent forces forms a closed polygon, then the forces are in equilibrium. That means it will be similarly the five. Suppose I am taking the five forces. In this case, F1, F2. Here it is the F3 and it is F4. This F5 like this. Then these are in the equilibrium. Then the polygon closes in this way. It can be forms five forces. It is F1, F2, here F3, F4, and it is the F5. Okay, it is the conversion of the polygon. If a system of congruent forces forms a closed polygon, then the forces are in equilibrium. Next, here before very important concept in the competitive examination point of view and a problematic point of view, that is Lamis theorem. Before going to the Lamis theorem, let us discuss about one important concept, that is free body. Free body. Free body means a body is said to be free body if it is isolated from all other connected members. That is simply in the hanging cases. For that, free body diagram concept. Free body diagram means the diagram drawn by eliminating the supports. The condition is eliminating supports. Eliminating Okay, eliminating the supports and indicate the actions and indicate actions and reactions. Indicate the actions and reactions that will be discussed while solving the problems. Free body diagram means the diagram drawn by eliminating the supports, indicating the actions and reactions. Okay, actions means it's self weight or any other forces acting on the body, whereas reactions means normal reactions to the contact surfaces. Okay, now coming to the Lamis theorem. It is a very important concept in the ECET and GATE point of view and in ECET point of view also. If three forces are acting at a point or in equilibrium, the concept is simply I am considering the three forces acting at a point or in equilibrium. It is one force and another force. Here it is the another force. If three forces, the three forces, let us assume it is the P, Q, R. P, Q, R. If three forces are acting at a point in equilibrium, each force is proportional to the sine of the angle between other two forces. So let us assume the angle is here, the angle between these two forces Q and R is taken as the alpha, Q and P, Q and P, and here the angle between P and R, it can be taken as the beta. It can be assumed the angle between the two forces, it can be assumed as the gamma. Now the statement is if three forces are acting at a point or in equilibrium, then their resultant, each force is proportional to the sine of the angle between other two forces. Each force is proportional to the sine of the angle between other two forces. P, suppose the P, each force is proportional to the angle between other two forces. What are the other two forces? Q and R. Q and R, the other two forces. What is the angle? That is alpha. P is proportional to sine alpha. Whereas, suppose take force Q. Q is proportional to what are the other two forces without Q? P and R. Okay, so P and R. What is the angle between P and R? That is beta. Then Q is proportional to sine beta. Next, coming to the third force R, other two forces are P and Q. Okay, the angle between the P and Q is the gamma. So then R is proportional to sine gamma, sine gamma. So from this, we can write. From this we can write the P by sine alpha, P by sine alpha equal to Q by sine beta equal to Q by sine beta equal to R by sine gamma, R by sine gamma. So it is the important relation to solve the problems in the Lamis theorem. Okay, if three forces are acting at a point or in equilibrium, each force is proportional to the sine of angle between other two forces. Each force is proportional to the sine of angle between other two forces. Sine of angle between other two forces. Okay. Now let us solve some problems. Before going to that, how can you get this relation? How can you get this relation? That will also discussed in this video only. Now coming to the first force, here let us assume the force P can be taken as, here it is the force P. Next, the Q, that means it can be forms a right angle, it can be forms a triangle. Okay, the other side is here, it is the other side. So here R. So based on the triangle of forces conversion. Triangle of force conversion is if three forces acting at a point are in equilibrium, then they can be represented by magnitude and direction by the sides of the triangle taken in order. That means here we are considering the three forces. We are considering three forces, so that can be forms a triangle. That can be forms a triangle. So now here it's a extension for the understanding of the forces and its angles also. Okay, now the angles here P, let us take it. It is the A, B, and C forms the triangle. Its angle is beta. Its angle is gamma. Here the angle of inclination is the alpha. Okay, now take P by P is proportional to sine of angle between other two forces. Angle between P is here. Sine of angle between other two forces. That means CAB. Angle CAB. CAB. Okay. Other two forces is alpha. Next, Q by sine of Q by sine of Q by sine of here Q. What are the other two forces? P and R. So the angle of ABC, angle of ABC. Next R by sine of R by sine. R is the, this one is R. So angle of ACB. Okay, angle of ACB. Then coming to P by sine of angle CAB. Here angle CAB. Okay, actually here this is angle CAB. So that can be taken as 180 minus alpha. Sine of 180 minus alpha. Total angle is 180. So we need this angle. Okay, we need this angle only. Here we need this angle. So here also we need the remaining closed angles. So Q by sine of angle of ABC. Angle of ABC. So for that sine 180 minus beta. Similarly, R by sine 180 minus gamma. So then it can be represented P by sine 180 minus alpha. 180 minus alpha means nothing but sine alpha. So P by sine alpha equal to Q by sine beta equal to R by sine gamma. R by sine gamma. So this is the different. Now let us take in problems on Lamis theorem. Determine the tension in chords A, B. So here it is the A and it is the B. Tension in chord A and AB and BC. BC here. Equilibrium of 20 kg block as shown in figure. Okay. So here, for first of all, we have to, for this type of cases, we have to draw the free body diagram. For that, free body diagram means, first of all, eliminate the supports. What are the supports? A is the support, C is the support. Okay, so eliminate the support. So here it is the support. Eliminate the support. So in this way, eliminate all the supports. Indicate the actions. The actions means at point A, it is the contact point. So here the tension will be produced. So it can be taken as the AB. So that's why it can be taken as TAB, tension TAB. Next coming to the CBC. So here also the tension will be acting there. So that is TBC. Next coming to this, here 20 kg. 20 kg mass will be acting here. Now coming to angles, angle resolution. So here its angle is from the diagram we can observe 45 degrees. Next here the angle is 30 degrees. The angle is 30 degrees. So it is the free body diagram, the procedure of the free body diagram. That means eliminate the support. We are eliminating this support and this support. Indicate the actions. Actions means self weight of the body. Here 20 kgs, it is the action. And reactions. Reactions means here tension will be acting TAB, tension will be acting TBC. Now find out the tension. Your target is you have to calculate tension in AB chord and tension in BC chord. Okay. So for that purpose, we know we have to apply the Lamis theorem. What is the formula? P by sine alpha equal to Q by sine beta equal Q by sine beta equal to R by sine gamma. So here for your easy understanding, I can tell alpha plus beta plus gamma equal to, here alpha plus beta plus gamma equal to 360 degrees. We have to get total value is 360 degrees. So please remember this condition. So first, same thing, you have to apply TB. Observe the first of all, in this case, this type of problems, you have to find out the angle between the two forces. So here it is the 30 degrees and here it is the 90 degrees. Why? Because it is the perpendicular one. So here 90 plus 30. So what is the total angle? Total angle is 120 degrees. Similarly, it is the 45 degrees and it is the perpendicular case. So 90 plus 45. So this angle of inclination is the 145, 135 degrees. Its value is 135 degrees. 90 plus 45. Next, here the remaining, here 120 and 135. It is very clear. So the total is 130, here 255. So the remaining angle is how much? 45 plus 60, 105 degrees. 105 degrees. So if you take total angle is the 360 degrees. Okay, total angle is the 360 degrees. Now apply the sine rule or Lamis theorem. First of all, TBC. Consider TBC by sine. What are the other two forces except TBC? TAB and 20 kgs. So what is the angle between these two forces? That is 120 degrees. 120 degrees. Next, coming to the next chord tension, TAB by what is the other two forces except TAB? That is TBC 20 kgs. So the angle is how much? That is 135 degrees. Next, coming to another force, that is third force, that is 30 kg. So here 30 kg by sine of angle between other two forces. What is the angle? Here is 20 kgs. Other two forces are TAB and TBC. What is the angle? That is 105 degrees. 105 degrees. So then we can find out easily. Now from this we can write TBC by sine 120, TBC by sine 120 degrees equal to 20 by sine 105, 20 by sine 105 degrees. And another case is TAB by sine 135 degrees, sine 135 degrees equal to 20 by sine 105 degrees. 20 by sine 105 degrees. So from this we can simply now TBC by sine 120. Sine 120 is 0.86. 866. 20 by sine 105. 20 by sine 105 equal to 20.70. So by the simplification, TBC you get 20.7 into 0.86. That is 17.93. 17.93 kgs in terms of the kgs. Next, coming to this case, TAB by sine 135 degrees, that is 0.707 equal to here 20 by sine 105 degrees. Sine 105 degrees, that is 20.70. Then TAB, this TAB equal to 0.707 equal to 14.63. 14.63 here K in terms of the kgs. In terms of the kgs you get. Whereas if you require in terms of the newtons, we can multiply it with 9.81. Okay. that is 17.93 into 9.81, you get 175.89 newtons, whereas here 14.63 into 9.81, that is 143.52 newtons. Okay, while conversion, otherwise first we may take this 20 kgs into 9.81 firstly previously. Otherwise, you can take 20 by 20 into 9.81. That's value is 196.2 newtons. So in this way, we can calculate the tensions available in the cages. So in the next video, we will solve the remaining problems of different cases of Lamis theorem. Okay, if you like this video, please share and subscribe Brunda Engineering Academy channel.